A telecom company wants to predict the next hour's network traffic based on current utilization, active user, CPU load, time of day, and previous traffic. We don't know which machine learning model will perform best. Therefore, we train 3 models and use MLflow to track and compare them. Let's get started and let's check these models and how we can use MLflow to track and compare them together. So first we import MLflow and then scikit-learn. As I mentioned before, scikit-learn is a very important library for machine learning models. Then we import 3 models. First, linear regression, decision tree second, and the third one is a random forest. Then the metrics, mean square error and mean absolute error and R2 square. Mean square error is the error between the absolute and predicted value, between the actual and predicted results. And the R2 square is a very important for coefficient and the value, which is the score, which is the explaining of the model itself. So high value in the R score, it means this is the best model. And low value in the error, it means this is the best value. Now we have used URI to push the data to MLflow GUI. Okay, now we have to generate and simulate network data, telecom network data. So I have generated 1,000 samples and generate a random values based on the metric that I have mentioned before, our active user, CPU utilization, cell utilization, and previous network traffic. Then I have generated the target for next hour network traffic. And also this is generated according to that code. This is a very important code. Train, test, split, X, Y, and the size. X, Y, now we have to split between the features, the metric that we have provide to the model, the information that we provided to the model in order to train the model itself, which is the X train and Y train, which is using for training the model. So 80% for training the model. Then the text size is at 20% for testing. So now we give X test. Now we are testing the model, generating another value for testing the model itself. Then we get Y predict, the result of the test, X test itself. Then we compare it with the Y test. So the minimum value between Y test and Y predict is mean that this model is a best and will perform best according to the provided information. So from the MLflow GUI, we have to open experiment, then a telecom network traffic prediction. Inside it, we have a training runs. Once we open a training runs, we can see those 3 models, select them all, and then press compare. Once you press compare, go down and you can see the R score, which is very important attribute that we have to check. High is best. So which one is the high? Is the random forest model. So this one is the best comparing with other models. So if we check these models, once we go to the training runs itself and open the model itself, we can see the artifact. In artifact, we have to see the prediction, and we can see the actual and the predict value are very close. So these numbers are very close together. Then that's why this is the best model that we have to go with and will perform best.